cloud. All right, we're recording. And I'm gonna share my screen so that we can start with the process of the slide. So right now, I want to take a few minutes just to ask if there are any questions. And maybe you guys, if you have any insights, if the group formation has been done too. I saw in the Discord that there are a lot of people who were very interested in working together, working in certain variables and certain problems. And I would like to hear your perspectives. If you can put it in the chat. If you have any particular questions, you can put it in the Q&A as well. And not only about the project, about anything in general, any of the tools that were shared yesterday and the day before. I shared the presentation with the WaterSoftHack team, so that's going to be uploaded sometime soon, very soon. And from then onwards, it's all about the training and the development of some of the projects. So I'm gonna wait a couple of minutes more. Let's see. Okay, let's get started then. So I'm gonna put up the slideshow. The presentation today is going to be similar to what we did before. We're gonna go through some slides where we're explaining about the whole process of data visualization, what that entails, different options, as well as the modalities of now you have your visualizations, you want to add some interactivity. How can we do this, particularly in the web systems that we have shown before, and we're going to probably review them, revise them, and see some other options that are out there publicly available by different entities. So there is something in the chat. Let's see. I see that not every fellow has joined. Okay. So just as a reminder, everyone, if you are a fellow, you have to join into the sessions so that we are enabling the collaboration part of these trainings. So just keep in mind that all of us have to be in here. And as well, please, any questions that you have, put it in the Q&A. Anything in general about the chat, put it in general that you want to share, ideas of projects, put it in the chat, put it in the Discord. If you have any questions, please reach out to any of us so that we can take a look at any of the problems that you might be facing. And yeah, I think we can move along. So this is the last day, data visualization. Data visualization, the main objectives that we have for today are, as you might imagine, what am I trying to do with the data? I retrieved it, right? I cleaned it. I do some analysis on it. I perform some either statistical model, I perform a hypothetical model, I do a combination of the two. I have some nice, good insights now. And then what? And what am I going to do with this data? How am I going to showcase it either in an academic publication? I want to go and present in a conference. How am I going to put that in a poster? Or perhaps I have now an interactive poster option. Can I add some interactivity to the visualization that I have? And so the objectives that we have for today are, first of all, understanding, taking a step back, and seeing the best practices. What is the process of visualization and the importance is that it has not only hydrology in all sciences in general. Of course, we're going to be focusing in here about earth sciences, and we want to understand principles about how information is being portrayed out there and what are the best practices that you can take and which are bad practices too, because we've been in conferences, or perhaps you've read a paper, a publication that it's out there that the science behind it is very interesting, very engaging, but they couldn't put it together once that is supposed to be in a presentation. Or the figure that they were showing, it wasn't clear. And this has happened many times. At least I've read many papers in which I find so interesting the approach, but then the delivery of the visualization part is tricky. And I understand, it's a lot of how much information I'm going to use within a visualization so people can be engaged. And so that's another of our objectives. And also expose you to the visualization tool. So we're going to be using the same as before, show you primarily web development through JavaScript, through the tools that we have developed and other libraries that are out there in the environments, both Visual Studio Code or the sandbox environments, or in the browser, and also through Collab, through the visualization libraries that are out there. And we're trying to create interactive and impactful visualization so that we can dive deeper into the projects at hand, correct? So what are the tools and libraries? As I mentioned before, the scripting of Python and also the interactivity of JavaScript. We're trying to show them to you during these trainings. So we're going to go again into HydroLang in another module. We're probably going to be using some of the Hydro Compute. I'll try to introduce the Hydro RTC so that you have a full scope of tools to your disposal. And we're going to be mentioning one of the powerful libraries that are out there for visualization on the web called D3. This is one of the many. And the main reason this one was chosen was because it has a lot of leverage and a lot of integration to new standards that are being put into the browser so that you're able to create more tools. So aside from that, we're going to use Python through the collab. I'm going to be showing some examples of data visualization. Python itself has a lot of different options for visualizations, which are really good, really helpful to get you from that, move aside the analysis, visualize, and iterate once again and once more. Now, tool for development, VS Code, online resource, Google Collab. Okay. These are, once again, the links for the development that I was sharing before. I'm going to be, we already are available. We are all aware about this ones, except this last one is the file folder of the collabs, but I'm going to share it in the chat. Everyone, there you go. So that you have those available once we get into the trainings, and once you can see the structure of what we're going to be presenting in the slides. So, okay, let's get started. As an introduction, visualization, of course, is key important because it doesn't really matter how much effort we put into an analysis. We can get a nice number. We can feed data very well. We can have a predictive model. But from there to show it to the public, to the interested parties, to everyone who is involved within this, the project ideas that you're developing, the visualization part is very important. Why? That way, there are many different ways of visualizing data. There are many different ways of putting the data out there too. However, seeing it from the perspective of there are bad and good ways of doing exactly that is key. And this comes from the audience. There are many types of audience out there. So how you show your visualizations or your analysis in a paper might be a little bit different on how you show it in a I don't know, in a website, if you want to show it in a video, because you have to understand, and it's, you know, it happens to everyone who is in the sciences. We get so deep into our science and it's so interesting, and we want to show more, but sometimes we get lost in translation because we're not able to democratize this information in a way that is accessible to everyone. So if you've lately submitted a paper into any journal now, they ask you for either a graphical abstract. You know, it's telling you, okay, all of what you did is great, but I want the straightforward, the idea that you're trying to show. So that is an example of a visualization tool that is being used for for showcasing our information, our data. It is a process that involves different types of tools. These tools are largely used. I'm going to be mentioning a lot of them. Probably you already know how, for example, if you have a process or a method that you're trying to show, flowcharts, a diagram, an infographic, Gantt chart, or an illustration, a timeline. These are really good tools so that you can see that. An example is a map also. You can have an infographic within a map that showcases the population densities in an area, for instance. In here in Iowa, how much is the population densities across the counties? What would I use then if I am going to create a timeline of the WaterSoftHack for the next week's deliveries? Probably a Gantt chart. What are my main goals and when am I able to achieve them once I go into those days, so that everything is clear, everything is out there. You can show this. We want to, if you want to compare, contrast, and show change, well, the usuals: bars, lines, bucks and whiskers, a bubble chart, stack area, a pie chart. All of them can be utilized for all these contrasts of showcasing data that is either similar or dissimilar in different ways. And all in all, what we're trying to do is establish relationships as well. And though you can do it through the tools that were mentioned previously, usually there are other ways of showing this, such as networks, heat maps, maps, radars, mosaics, Venn diagrams, etc. Why is this important in hydrology? You can tell me about your sophisticated model, and I might be able to understand most of it. But if you go into the public and you're trying to say, hey, state senator, I am there's a flood risk from the different rainfall events that have happened, what will you show? If you tell a story, that's fine. What is the best way to show it? So what we're trying to do is enhancing understanding through the simplification of complex data and the identification of trends, patterns, and anomalies, but putting it out there in a way that is easily digestible by everyone who's involved. We're trying to maintain better communication by facilitating finding diverse audiences that it's not just the domain-specific audience, but also policymakers, public. If, for example, you have a public website, you're showing your information, what you want to share is available for everyone. So people might be confused about how you're putting the data out there, or confused about why did you use a heat map instead of a simple graph for showing a trend line. And that's the kind of thing that you have to understand about what on the decision-making process of your visualization tools. So we're trying to make better decision-making for superior data, everything, right? Data acquisition, data management, data processing. Okay, so now I'm going to go into the different types of data visualizations. So we all know about this one: line charts, pie charts, bar charts, heat maps, scatter plots, histograms, maps. All of them are being used across different things. A bar chart is great for comparison. Quantities like yetographs. So if you have a rainfall event, you want to compare different rainfall events, put it in a yetograph, can show you those differences in volumetric data acquisition. If you want to show the next steps from a trend line, just as we were saying before, a seasonal decomposition in a time series, probably line charts would be best. If you're trying to show ballots through the I don't know, different locations in the US, a pie chart would be really easy to do. Heat maps are interesting for displaying density and intensity, not only regarding data. So heat map, I've seen a lot of heat maps that are being used for showing also when you're training a model, when you're training something with data intensive, where is the training going towards in the 2D landscape of where you're training things. And this is very interesting how people utilize all these tools to showcase their data. Histograms are grants for frequency distributions. You can fit within the distribution a line chart too, and maps, which is on its own a big component of the visualization parts. Now, there are principles for effective visualization. So as I was mentioning before, you can really lose the focus of what you're trying to say if you're not putting it together in a correct way. So right now, I want to discuss some of the principles for data visualization that are out there, best approaches. For example, clarity. Clarity means ensuring that the visualizations are easy to understand. So many times, less is more. You don't have to put all your graphs, all your charts, all your trend lines within a single chart. You can separate them. There's, I know that there's sometimes space that you require, but sometimes separating things isn't as difficult as that. And in here, I'm showing, for example, the good and the bad. I'm not going to say what the good and the bad is. I hope that it's clear. However, clarity represents using clear labels, legends, titles, focusing on what you're trying to say, avoiding clutter if you have a lot of excessive details, adding grid lines in a line chart. I've seen examples in which the grid lines, only the vertical ones are necessary, and that's more than enough. Sometimes it's just the horizontal ones, that's more than enough. I'm not saying that what I'm showing here is particularly something that you would like, but definitely the right one is a little bit easier to understand than the left, correct? What's another one too? Accuracy. Accuracy is representing information truthfully and precisely. We're not trying to show something that is not. We're trying to keep the data that we're showcasing to truly represent what we want to highlight. So avoiding misleading representations, avoid, you're a researcher, your data wasn't showing what you expected, but you say, I don't want to do this. I don't want to do this analysis once again. I'm just going to plot what I have as it is. And that's a clear example of, what are the steps that you would take then to, in a way, maintain accuracy, but in reality, you're just misleading all over the place. So this is a clear example, very simple. Again, groups, if you have these scatter plots with different categories, different values, why not just rescale some of this information so that you can show more, right? I don't need to have my values from -1 to 2 on the left side of the screen, or maybe it's going to be on the right side, but the red labels, I don't need to have that scale there because I cannot really see properly if the data is fitting within for each of the categories on a specific range. But if I zoom in and I rescale, I can see that, oh, okay, there is quite a significant differences between each of the groups. So the left, I had groups all merged together. On the right, I'm separating everything so that there is a clear understanding of each of the groups categories. Simplicity. What is simplicity is having your designs straightforward and focused. How do you do this? There are many, many different ways, but the best is use colors that are friendly to the eyes. I'm going to be sharing right now. I just came with, there is this tool out there that can tell you for people who have color impaired vision, different ways, different color palettes that you can utilize. And that, just with that, you're already, through a simple approach, reaching out a wider audience, right? The other one, perhaps the separation of all of this information, as in here in the pie charts, is not necessary. Perhaps groups, as it's in here, groups A, L, and K can be merged together. B is pretty big, but perhaps a little bit of C can go into B2. It depends on the case. I'm not saying that is correct or not. Perhaps for the case in left, other type of visualization might be best. Maybe a bar chart that is multiple bar charts, not just a single one. But in the case that you can simplify your data so that you can put it out there in a single cohesive way, then that would really add value to to what you're trying to say. Right? So highlighting the most important information rather than putting everything within a single space that is just going to make you and make everyone else confused. Aesthetics. So I know that aesthetics is a very subjective term, indeed. What I find appealing is not necessarily what everyone finds appealing. And so I can tell you what I like. You can tell me if that's okay or not. But there are definitely some things that we can improve in our graphical representations to make things a little bit easier to read. And many times, if you're making things easier to read, you're already having a better aesthetic approach. So in here, again, you have the left side, everything is gray. The grids are, not necessarily I already have the bar charts going up. Do I really need those for the categories. If I already have the categories there, can I perhaps have a better outline for it? Just the borders outside can be enhanced. And that's what we're trying to do with the right side. It's not, it isn't a huge difference, if you can see, of the changes that we made. Change the color palette, change the outline, add a little bit of more features into your graph. And that's the change in 2 or 3 lines of code that really makes a difference in saying, now I can put this in my publication. Now I can put this in my poster, or perhaps now I can use it as a static asset in my web application, right? So balancing visual elements for enhancing readability, it's always important. Now, I wanted to just show a couple of more examples that, to me, look good for showing data. So, for instance, we have a heat map in here. I'm saying again, this is something that I found that it was interesting. And that way I'm showing 2 different groups, 2 different categories. 5 different categories. And through this, I'm saying, okay, this is what's most important through the color scheme. A simple color scheme that goes from red to the most impressive and down to very blue, right? Simple, but yet effective to portray the ideas. Same with the box and whiskers. Box and whiskers is just showing, okay, what's my part tiles, what is my median, what is the mode, all those descriptive statistics put together in a very simple way that shows you values and categories in a straightforward manner. And finally, you have a histogram. You can perhaps put through this frequency a little line that shows, I don't know, maybe a distribution, maybe something similar to this. So these are just ideas that we wanted to show on best practices. And of course, the maps and layers, that's something that we need to talk on its own. Good practices in maps and layers, you really need to have clear labels and minimal clutter. If you see a map that has all the grid lines, all the lat longs put there, and what you want to show is a rainfall station, then maybe there are better ways on doing that. That doesn't mean that you remove everything from your maps to remain simple, because then what are you trying to say? I need some of the relevant features of a map, northing, the station-wise. If I'm showing a gauging station right here outside, how am I going to understand the location, right? So different ways of putting those maps together. Showing you in GIS programs, you can do many ways of that. If you do it in web-based systems, a lot of the maps that are out there already have very minimal layers and very minimal information that is more than enough many times for showing the ideas. So again, truthful representation of the correct scales and proportions is important. Focus on the information that you want to show. Do not put so much effort on everything else. Because in the end, if you're making a map, if you're trying to highlight something within that map, then that should be your primarily interest. Of course, it needs to be readable. So the text and symbols have to have a good contrast with the background of the map. So, selecting a very purple map and putting a black background to it perhaps it's not the best idea, right? So keeping all of those ideas in contrast is always good for you. Bad practices is exactly the opposite of this. Clutter with excessive data, it is misleading. It's not telling me exactly what I want to know. Misleading legends and explanations, different. Oh, and at least that's a quirk of mine. You have varying styles throughout a presentation or a map, then that means that perhaps some more time was required to create the final product. Sometimes different styling is good. Using same fonts, using bold, using italics, having different formats, it just shows cluttering in your ideas. And this is a very nice example that I found at this bad and good maps. So these are conservation easements within the United States. And in the upper left corner, you can see a lot of cluttering, and it might show you, there's a lot of data over there. And of course, that might be true, but when you zoom in, you go in there and you have exactly the same information, then you see that it wasn't really as was mentioned before. So I guess that's the interactivity part of the maps that nowadays we can toggle along and actually test out what's being shown to us, right? So what do you need to do? Choose the right visualization type. It's always trying to match data that you have with the message that you want to convey. Examples, line charts for trends, bar charts for comparisons, heat maps for spatial data and correlations. Truly state the labels and layers in your maps and make the best out of all the clutter that you have. I know that you deal with a lot of information. I know that for us, the science that we do is interesting, and domain-specific people also will find it interesting, but someone outside that might have a say on this might get lost in translation. So try to avoid doing that. So those are best practices. I'm going to shift gears now into showing you the tools and visualization that we want to showcase. I will make a little bit of a stop here just to see if you have any questions. Please put it in the Q&A. If you have any other suggestions as well for chats, I'm not saying that what we put in here was just the ground truth. Perhaps you've seen something interesting that some other people, some other researchers, or people outside of the research media has done, and that you find, okay, well, that's a very really good visualization. So if you want to share that, please put it in the chat so everyone understand and can see more examples. Right? Okay, so tools for visualization. We have already discussed several of these tools. Right now, we're just focusing on JavaScript and Python, but again, these are not the only things that are being used. Some of the only programs that are being used for visualization of information. There are many programs out there, many programming languages out there that have amazing tools for visualization. R is one of them. You have the ability to put your maps and embed the data right into that. I love that. You can do that also with JavaScript. You can do that also with Python. So that just means it's different flavors to achieve the same things, right? So you need to see what is the best fitting to your specific use case. Again, JavaScript for web interactivity, Python right now for the analysis parts. That's our main focus. So we have talked lengthily about Hydroline. We haven't seen, though, of course, we have seen how you put some things in a map, how you create different examples of those maps and put layers to it. But we haven't really delved into how to actually do it. So It has, through its API, two different visualization modules. The first one is Visualize, which gives you access to Google Charts. Uh, Google Charts itself has tables, different types of charts. So histograms, line charts, scatters, plots, all of those. We simplify the process of creating many of these into Hydroland so that you call a single function called draw that has many different customization options. If you want to customize your chart and then embed it into the web application, or if you want to just show it, you don't pass any customization, you just call the function draw a chart, draw a line chart. We also have the map engine, and the map engine has two different options for Google Maps and for leaflets. So for Google Maps, you need to register. So up to a point, it's free. And then you get an API key. You use that API key to access the Google Maps. Once that's downloaded, when you declare the hydro.map.render map, then that's going to be embedded into the web application, and you're going to be able to utilize it. Or the other option, which is Leaflet. Leaflet is open source. You don't really need to do any registering. It has the ability to render different types of tiles. And by tile, I mean, the background of the map that you have that can be changed. So we are going to be talking a little bit more about this function analysis afterwards, but I wanted to mention the other options for rendering on the web. So on the web is D3. D3 is a very comprehensive and flexible library that allows interactivity in dynamic data visualizations. And just as another worth mentioning one is Plotly, which is easy to use for creating dashboards, for creating charts. Now on the Python side, Python has many different libraries that you can use. Matplotlib is the main one, and a lot of the other ones are just flavors of Matplotlib, so they've included different things on top of it. It is a standard library for chart generation. It is highly customizable. Sometimes it might be a little bit tricky to manage. However, if you want a simpler version of Matplotlib, there are libraries for that. If you want the full customizable option, you can just go directly into the nits and grits of the options. Seaborn is another one. I like it a lot because you can create really good heat maps and relational visuals with Seaborn. Again, it uses some of the features from Matplotlib. And Bouquet, which is for interactive visualizations. So we're going to be covering some of this today. For the tools regarding mapping and layering in visualization in general, we have ArcGIS, QGIS. You can do a lot. Well, you can do everything within those two. The difference is that one requires a license and the other one is free and open source. And of course, open source software is great. However, sometimes it's, that means you have to consider many things when utilizing it, such as if there's support, is it going to be deprecated? With the other side is, okay, probably it's going to be stable for quite some time. Or if not, they're going to tell me, and then it's going to be an easy migration, right? But you can also write, if you get into the whole programming scope, you can write really cool features using Python in QGIS through GDAL and OGR. GDAL is this huge library utilized for analyzing spatial data. So I can show you some of these features in GDAL afterwards. And the online resources, Google Earth Engine is recent. I'm not really sure when it was out, but it's this powerful. It has a good backend. It has a good front end. It has data connections as well. and it's JavaScript based too. So that's a good option if you want to explore. For the folks that are doing the capstone, you can use some of the features from Hydroland. You can use some of the features from other libraries and integrate them in the Google Earth engine. And another one that is worth mentioning is OpenLayers. OpenLayers is this high performance engine for rendering GIS on the web. So we can go ahead and take a look into those. Before I move forward, there is 2 questions. Let me see them. Volume and Hydrolang from mapping data. Gmap, another pool, GeoPython. Oh yes, Gmap is another one that I didn't mention before. Thank you so much for sharing that one. I'm going to put it in the chat. Volume. I'm not really sure what volume is. If anyone else knows actually, or let me just, I can. Let's explore it here. Oh, okay. Python conceivable mapping. Okay, so it's based on leaflet. Okay, I see. So let me go back into the presentation. So volume then is, I'm guessing it utilizes as backend the leaflet engine. Hydrolang uses the leaflet engine as it is. So I'm not really sure if leaflet was created. Well, leaflet must have been created first, and leaflet was web-based. Maybe it wasn't. Maybe it wasn't C. I'm not really sure. We can see that later. But thank you for mentioning that. So yeah, if you guys want to take a look at what leaflet is, it's Python with leaflet through volume. So, oh yeah, you can create vector raster HTML. So the good thing about leaflet, and I can put in here so we can take a look. Leaflet is this, it has been out for a while, 11 years, and it has a lot of support. And the good thing about it is that you can declare maps fairly straightforward. So you see in here, you say, okay, you have an object. This object has different functions. You attach a namespace for that object. So this map that is in here has a div, so a divisor within this website called map. And so once you pass that into the this function, then you get another function available that sets the center of a view. So you center the map by providing the lat long, and then you provide a zoom. And then this is the different tile options that I was mentioning with leaflet engine. Tiles are provided by many different people. And the only thing that it does is this one, for instance, it's from OpenStreetMaps, but there are folks in S3 GIS that provide, if you see Google Maps has its own cost, its own what's it called? Its own tile as well. And tiles are very interesting because depending on the use case that you have, sometimes a black tile comes better and looks better when you're trying to show some layers. And yeah, so that's just a little quick about leaflet. Okay, so advanced visualization techniques. So that sounds a little bit more than what it means. What it means is let's add some interactivity to our tools. Why interactivity? Is because many times a static chart might be beneficial to allow scrolling up and down to get more insights, right? So These web-based tools, what they do have is that constantly you're able to interact with them. And the engine providers, so Google, for instance, or the three people, they make sure that whenever you are attaching a listener or you're attaching a a listener or some kind of other interactivity that you need, like a mouse up or a mouse down or right click or left click, that the engine understand what it's supposed to do. And that is really good because that means that on our end, the only thing that we need to do is to implement it, because we don't really need to go into the engine of the browser and tell it, hey, I need you to zoom in. Whenever I scroll in, you need to zoom in. No, that's all being handled for us. What is an example of the interactivity is, well, again, charts, enhancing user engagement and data exploration. So I'm thinking of when analyzing some trends, if you have a fixed boundary, if you have a fixed domain, and you want to know more about it in the middle, for instance, or a section of this, the composition that you might have created, you will need to rerun, but adding this interactivity can be done fairly straightforward. Maps, of course, a map should be interactive so that you can explore data and move around, right? And if we bring these two together, what you have is a dashboard. So a dashboard is a combination of data analysis, of charts attached to this data analysis, of maps that have those charts and have more information with them. And we have seen some examples about this before. We're going to be exploring some more of these other examples in the next slides. So if you have a project idea that would you like to further in, I would suggest for you to create an outline of a dashboard. A dashboard can contain everything that you want. For example, a map. This map can render stations. The stations can be clicked, and then you get some data from over there. You can report it out for each of the stations. You can report out if there's an issue or not. Just a quick up on top of my mind, you have a nitrogen or some sort of a contaminant sensor out there, and you apply some functions to those readings. And if it surpasses a threshold, you change the color of the sensor and says, right now, I am reading much more than I should. And that interactivity is simple to really do. But it's quite insightful because then we can take decisions and say, hey, there's something wrong with the sensors out there. There is a chat. Let me see. Okay. So thank you, Mohammed, for this. And definitely, this is a good question. So installing Jira is challenging. Within the Jupyter's environments, you can do a lot of it. Thank you so much for sharing this information. It's great. I'm going to open it up so that we can take a look before moving forward. There. Resources for GDAL out there. Again, GDAL, you can use, I think you can use it. It's Python, R, there's C, C++ options too. So I think it's worth mentioning that many of the languages that we use and are familiar with, they are built upon these other compile languages. So JavaScript is compiled not from Java, but from C++ and Python too. So sometimes when you get into a problem and that you feel that the language is not enough for you to solve that problem, perhaps going into these scripting languages, which is scary because, well, it's not scary, but it might be scary if you don't really know a little bit deeper about software development. But you might find the solutions there. So yeah, thank you so much. There's Python, RStudio. So for the web, there is, I mentioned yesterday about WebAssembly, the standard of creating binaries of modules that you write in different languages, such as, again, C, C++. There are folks out there, researchers who are making the effort of taking these tools from GDAL, some of them, create binaries of WebAssembly, and then put them available as packages, such as the package that I showed with Hydro. I can, let me see, in NPM, I'm going to show you an example of how that looks. So NPM is the main repository where you can find some of this. Some of the packages are great. Some of the packages, I wouldn't trust them so much. And I think it's GDAL. There you go. So there are some bindings to GDAL that you can use, and it's a lot of WebAssembly that has been rendered. And how do you do it is, for instance, you have a TIFF, and then you can get bands, you can rasterize, you can get sizing, you can transform, understand vectors as well. And all of this is JavaScript. So they have a lot of support, not all of it, because there are some limitations to the web still, which are going to be removed hopefully soon. But thank you, Mohammed, once again for showing these tools. So I'm going to go into some of the examples of the data visualization dashboards. I showed this one on the first day, which is a combination of the Hydro Compute and the Hydroline. What do we have in here is some statistics of RMA and auto-refitting RMA. Well, we weren't trying to do any forecasting. We were trying to see if the WebAssembly would work, the compilation would work, and if it made sense. But what am I trying to showcase in here is this is a very simple dashboard. You can have some text that tells you, okay, well, I have my information here that is explaining what I'm trying to do. I have some decisions through buttons, through lists, through a map. The map has interactivity. I can zoom out, I can zoom in. Perhaps these data sets can be changed. Perhaps the locations of the data set can be changed. I can do it by having these hovering options, and I hide or I unhide things. I can put like a pop-up as well, which all of this, though it seems difficult, it's really just calling particular things in the HTML. So a lot of this is being handled by other engines or from the cascading style sheets, correct? So I showed this example before. I'm going to go into, let's see, yet. This is just counties, different counties. And if in here, this is refreshing. So again, interactivity, right? Once I move into a different county, you see, if there's nothing, it's going to say, hey, there's nothing. If there's something, it's just going to map it. So this is making requests to a data source. The data source then cleans it up and then afterwards puts them in the map. I can select some of these retrieve stations. So I click a button, they disappear in here. So I can see if there's a button that appears or disappears. I can, you can visualize that on the go. And then what do we have? More information about those particular stations that we have, right? And then attaching a chart. So this is a different way of attaching a chart. As we showed before on the example yesterday from the Hydro Compute tutorial, This one is just a simpler way of visualizing data. How do you, within a single place, you can get all this information and insights in a meaningful way. This is, of course, there's a lot of improvements that can be done, but gives you a good idea of what a dashboard will look like. Different ones, though. The weather dashboards from ArcGIS show you even deeper and better examples of that. So forecast for locations, winds. This is looking into Adelaide in Australia. Sorry, I'm going to mute this. And you can select different locations, for instance. All of this is making just API calls all the time. Once those API calls come, show you this nice stations. And you saw how the tiles changed based on, well, this is ArcGIS, so they have their own tile systems and they have the ability of changing them based on the calls that they're making. But still, it's very interesting. It gives me an idea that perhaps going for the summer in Australia right now, in the middle of Australia wouldn't be a great idea, but in the outskirts, it looks pretty nice. Another example is IFIS. So I'm not sure how many of you are familiar with IFIS. This is the in-house flooding nation system for the state of Iowa. If you see, what you have is a big map. This big map has a delineation of all of Iowa. You have some general information about it. You have some tools that you can, by hovering, I'm not clicking anything, just hovering. You get toolboxes, you get custom layers that you can add. You can get alarms. You can get information about stream gauges, rain gauges, rainfall. A lot of this, of course, is data that is managing here in at the university, but a lot of it is also making calls outside from resources that are being given. So same idea, right? We're trying to do is, what is the best way of showing this data to the public? And through this modalities of, putting an SVG or an image of a community there and say, hey, this is the community view, that tells a lot to people. You don't really need to say much else. This one about flooding conditions, hey, it's a cone. So perhaps that's a way of saying, I want to share this. Let's say that I want to select one of the stations, and Iowa, again, we have had a lot of rainfall the last days. So you see if there's warnings, you can take a look. So if I click on one of these ones, you can see stage information, right? So go inside. This is a preview. If I hover over it, just move my mouse inside, you can get stage information. You can get, you see that there is a stage gauge. If you click into more info, then a pop-up just shows you that at this particular station, it's a USGS station. It's as of now in flooding stage. So what are we trying to mention in here? You try to make data accessible so that you as the public or you as a researcher can take decisions, correct? So forecasting, just saying, hey, look how the water level is moving, and all of this is pure interactivity of an engine that is rendering this movement. So another nice example for use cases. And one of the last ones is this one, dashboard for water data USGS. So I think this is fairly, it's not new, but there have been added a lot of different things. In particularly in a web application, sometimes it gets laggy because not only are you rendering a lot of information at the same time. So by rendering, I mean you have the visuals of the maps, you have the visuals of the little points that you're adding over there for stations or for any other kind of point of interest. You have layers that are being added so that you as a user can select more things. All of this add up, particularly if you're making requests to a separate API. So if sometimes you cannot really control that lag time that you have, sometimes they tell you, hey, we have a lot of people that are making requests right now, so probably you're going to get a delayed response, and that's good, that's fine, but just keep in mind that sometimes you are going to get some lags. Even calling leaflet sometimes, calling a tile provider, that might take a couple of seconds. So I'm going to show you quickly how this looks. This is extremely cluttered. And I'm not going to say that it's good or bad. I'm just saying that for my take, it's extremely cluttered. And it tells you a lot of really interesting information. So I'm going to zoom in into Iowa once again. Wow, I didn't realize that this was going to be as Yankee as it is. Going around a little bit. I'm going to go back into Iowa to that particular station that we're looking into. If I'm not mistaken, is this one. You click on this and you see what just happened. The dashboard asks, oh, this is groundwater service. And it asks, it makes the API request for a particular station. And then once that's back, it renders the chart. The chart is just this interactivity is the things I was talking about. And how do I go back? How do I go back? There we go. So if I drag my mouse, it gives me some of this interactivity back. If I double click on it, it renders back. So, give me full customizable options for for what I want to see, right? Removing layers, adding layers, all of this is, of course, it depends on the use case. It depends on what you want to show. It's not necessarily that you add all of these things into an application. This is, from that data life cycle that we were talking yesterday, they all went already all the way into the production stage. So the production stage is the most crucial one because you have to guarantee that what you have is reliable. You have to guarantee that the information is going to be there whenever it's requested. You have to guarantee many, many different things on the stack of information that you are telling the people, yes, we have that. So we're not at that stage yet. We're just researchers. We're just trying to get more insights. We're trying to learn more about both web applications and the use of different tools for portraying our research. So take that in mind. There's a lot of inspiration. Many times you can get some insights of how they did something if you take a look at the console, at the inspect of a web application tool. So say that you like, I'm gonna go into this one because I'm a little bit more comfortable with this, showing you this one. Say that you want to see how this was separated, right? So you have the location with the paragraph, and then There's these two different screens, and then there's this other stuff. So if I click on one of these and I say inspect, you're gonna see some either errors or resources. This is the fitting of the data that was done by the hydrocompute. By the way, that's where you see all of this outputs in here. But I just want to show you the visual, right? So the visual part is I have two different spaces. One of them is all of this. I have a navigation bar. I have one container in here that has everything else. My paragraph space, another paragraph space, the rows. So this particular example was created using something called Bootstrap. And I'm not sure if you guys might know about that. If you want to take a look, I'll put it in the chat too. Let's see, which is an easy way of customizing your applications because they already have built-in you don't have to add the interactivity of the cascading sheets. Just call this library, you put it in your HTML, and then from your HTML, you're able to get different things. For instance, an example in here, which is a good example. Let's see. Headers, sidebars, different features too, drop downs, footers. How do you create those? How do you declare them? Again, it's just HTML, and HTML is fairly simple. So you see, this looks visually appealing. So there's back into the best practices that we mentioned before. It's clean, it's clear. Of course, this is just an example of HTML, so it's not rendering anything. It's not attaching any interactivity to it. However, it looks good, right? You can go into the documentation. The documentation has more information about it. The way you do this customizations and is, for instance, I'm going to show you an accordion. An accordion is a nice way of seeing an example. So an accordion is this, right? The different things. How do you do that in HTML? Just pure HTML and CSS. It's probably going to take some time. I would recommend, hey, look at how they did it in here. A divisor, then you attach this class declaration in here, and then you say, hey, this is an item here of this accordion, and this is a header of this item, and so on. You know, you take a look. And the good thing is, once you download these libraries and you put them in your application, you save your HTML and say that you are working either in the websites that we provided, in the sandbox environments that we provided, or you're working in your HTML. You save, and then you're able to see on the go those changes. So that makes it easier for you to make decisions on what to use. Carousels. I like this ones a lot actually, because you can attach different things to this. This one can be a map. By clicking here, this can be a description of that map, for example. Okay, we covered quite a lot with this. So I'm just going to go ahead and talk about the best practices for dashboards. Always consider that you are the developer, yes, but who are you trying to develop this for? Are you trying to show it to someone? Are you trying to make money out of it? Are you trying to portray your research out of it? But who is the one who's supposed to see? So user-centered design is always key. And there are many resources out there that you can Google, or you can, now with AI, you can even ask ChatGPT, hey, do you think that this is appealing or not? Or maybe create a button, maybe something similar on how to style up your applications. And I'm just talking about web applications right now. We're going to go into the visual aspects afterwards of how to create better charts and whatnot in Python and JavaScript. But since we're almost wrapping up with the training, giving you all these tools is primary. So simplicity and clarity wins the race. You don't need to add a lot of information, just as that previous to last site that we saw, it was just too much. Probably for what I needed, I would just close it right away and try to find some other resource, right? Consistency is key for wider adoption, so try to remain consistent in your funds, in your the declaration of the things that you're trying to do. If you have a map, if you have some layers, some of these layers, once you get into the how-tos of this, you are able to see that you you can modify your site or the way you're visualizing things to tailor for your data sets, to tailor for what's the best outcome that you're expecting from this, right? And based on this consistency, if you're adding a lot of things, that's going to have an issue with performance. Performance is always a problem with, well, specifically web applications. From what we explained previously, web applications are running on a single thread. So at the same time that I'm making the API calls, the HTML is rendering, the CSS is attaching all the colors. And if I am a user that is a little bit desperate to get my information quickly, then each time I click something, that is a request that I'm making to the application. So that means that I need to wait and then delay, and then that's when the web apps crash, when they clog. Enable interactivity across your tool. Hey, interactivity is good. You have a lot of ways of doing that interactivity nowadays. So why just not use it? So example case studies. I'm going to start with these examples right now. I don't think I'm going to be, unless you guys tell me that you're tired and you want a little break, I'd like to continue moving forward. So yeah, I'm going to leave that as a question. If you put it in the chat, hey, let's have a break right now if you want to stay a little bit longer for that 10-minute break before I show this example. So if no one says anything, I'm going to assume that we can continue moving forward. I'll give you a minute. Okay, there's a response. Let's see. We continue. Okay, great. So what we can do is we can continue all the way until maybe 11:45, 11:50. So sorry, 20 minutes from now, 30 minutes from now. So that way we can cover more things. Okay. Let's see. I'm gonna close this part. And I'm going to start with the web applications. So I'm going to start with this example of visualizing a shapefile on the web. So shapefile is a vector type of information that it isn't as straightforward to put in an application, but you can definitely transform it and transform the features within it. There might be some not performance, but some quality that might be lost if you transform from one thing to another. However, it depends a lot on the use case, correct? So I'm going to show you a quick example of transforming a shapefile into a GeoJSON. No, I'm not going to show you the example of shapefile to GeoJSON. You can do that in QGIS. There's fast scripts that you can utilize for transforming this through GDAL in Python. And you get a JSON object or a GeoJSON object. JSON, GeoJSON, the semantics in there is a GeoJSON is a JSON object. And then we're going to grab this JSON object and put it in a map, in a leaflet map, in a Google Maps. And in particularly for this case, we're going to be using D3. So the library that I was talking about before. Before I go into the needs of the library, I'm going to show you an example of how that looks like. And attach a layer to a visualization object, right? So copy this. I'm running it in the local environment. In the online environment. In the stack blitz, right? So I'm going to paste this in here too, in case you want to take a look in the chat. See V3. Okay, so it's still installing some dependencies, so I'm going to go ahead and start. This is a very simple example. I have a GeoJSON. This GeoJSON is right here. It's pretty big. And the GeoJSON contains, as a point, circles that have data of a city. So all the cities across the world that have a certain degree of population, I don't remember how many population was it, but yeah, all the cities in the world that have a high population density or that have a lot of information. This was an example that I grabbed from a resource, this GeoJSON file. It's not about the GeoJSON, it's I want to show you that the transformation from the shapefile to the GeoJSON, then afterwards I can grab, using QGIS, right? I can grab the an attribute, attach that attribute into my GeoJSON. From the GeoJSON, I have this nice structure and I call it this feature collection. The feature collections is for each point, I have a coordinate and I have properties for that coordinate. The properties are coming from the features that I selected from the GIS system. And then this is just an example of population. This can be anything else because this can be for our domain, right? How many stations do I have in a city? How many as a number, right? Or concentrations of a certain pollutant, or it can be forestry areas. It can be anything that you would like to export, put it in a GeoJSON. The GeoJSON is fairly small. The files are fairly small, so that makes it easy to render. And if I go into the index HTML, the way we did this part, and it's not, let's see, yeah, I'll show you like this. Oh, a lot of cities, right? A lot of density in Asia, in here in Europe, a lot of density of crossing here in the US, and not so much in the Sahara, which is expected. How did we do this? We had a header. Inside the header, we put the content, and then just as we did with Hydrolang, there is this content delivery networks. D3 is a pretty big library, so they just make a call into one of the versions of their libraries. Now it's made available for us. This is completely unnecessary. I just put it in here to make a separation. What's a body? What's a feature? This is the stuff that I was telling you the Bootstrap does, this library for you by declaring an HTML and putting in some attributes. So the attributes are whatever you pass. This is an attribute, for instance, in an HTML element. And so once you go into the declaration of the HTML element, you say, okay, this is my header, H1, D3 GeoJSON visualization, and I do declare a map div. And this map div allows me to put the data right over here once I'm ready for it. I declare a width and a height. This is in pixels. And then I use the D3 library for rendering that. So D3 has a lot of different features that you can expand on for SVGs. So SVG, the different image formats out there. Right now, I'm using an SVG. So what you do is you grab the ID of map through D3. So D3 looks into your HTML and then appends an SVG format with the following attributes. So you say, hey, the width of this element is this. The width of this is his. It's not it is necessary to append, but you can also put these attributes right here in the style, but that's just HTML, basic HTML. We're not trying to show you basic HTML. It's more about using the libraries, right? Then I did GeoMercator, so I changed the coordinates by calling in this function. I rescale, and then I translated all my rescaling by half of the width and half of the height. Then again, I used another function called GeoPath, and I attach to this path object the projection that I did before. So this is going to be a number. I put it in here, and now I have this path element. Then I use, again, the library D3 with JSON. So it's going to read the element in here, my example.geojson. After reading this, I don't know if you guys remember yesterday, we talked about the synchronicity of the web languages. So D3 has its own way of doing this, which is a little bit on the old style of how you used to do this for making API calls, for instance. This is basically when you're reading a file from your local directory, it's basically an API call. That's the browser or the engine that you're using is basically making an API call. It's just, hey, I'm going to fetch a URL. So it attaches a fake URL and then looks into your system and then reads it, right? Once that's done, once that's read through this, so what it does is, it takes a look and then afterwards it parses as in GeoJSON, as JSON. Then with this data, which is going to be a JSON object, so you can manipulate it and you just attach it. So all of this is just styling. So you attach the data through the features. So again, I'm gonna open this one. You have in each GeoJSON features, all these features are the geometric information for the library you're trying to, the data sets that you're trying to put in your application, and you attach these features over there. And that's exactly what you do. Afterwards, you append the path. So this path that we declare in here, and the different attributes for styling. You can style, you can append, and if you see, everything is just this dot notation. So it's a big object, and you're just attaching things, attaching attributes. And there's many ways of doing that. I'm going to show afterwards the D3 library. So this way of doing the reading of the data is called a promise. It's a promise kind of based way of reading by D3, by the D3 library. So if you read and that's successful, then do it. If you have an error, then catch it. So you append this catch here, and then just log the error that you had. And I know that seems like a lot, but for starters, you can just use exactly the same code and try to modify these colors. You try to modify your path. Perhaps the space where you're rendering this might be different. Correct? So that is one of the examples. This is the library that I was talking about, D3. It has many different features. And the examples, the folks who developed this also developed this I think it's a observation, it's a dashboard for building code. There is some support also for Python. So if you are venturous enough and you want to take a look into it, you can. But the idea is, you have graphs, you have also some maps, these are GeoJSONs, scatter plots, connected plots. You have zonifications as well, subable maps, many different types of interactions too. If you click on one of these examples, and you can just look into D3 I can just share that in here, 3.js. If you want to see into one of the examples, let's see one that is interesting. I really like these threading kind of charts, arc diagrams. Maybe that's going to be too much to see. Let's see. Well, this a bubble map, right? Bubble map, it has all this nice information. All of this is just being done by D3. It has a lot of different features. It is a steeper learning curve, and I agree. I'm not trying to say that it's straightforward to use, but there are many examples out there that you can just modify, and then you have the interactivity that you require. Right? So you have your data, you did your processing in Python, you saved your data or your processing shapefiles or any other type of processing tools in R, then you dump that into a JSON or you dump that into a CSV or any other format that is accessible by the libraries that we've shown, idlelang, idlecompute, D3, and in Python as well. And then you just use some of the same codes examples because you're not going to be changing much else. So yeah, just a lot of this is just attributes. As you can see, it's highly customizable because you can do transformation of colors. If you make a click and you attach that there, if you have a circle, for instance, legends, different formats, the reading itself is not as complex. You create here, you read your paths, and then you move to the next steps. If you're more comfortable with Python, I understand. I understand that this might seem a little bit too much, and we're going to be covering Python too. And I think we can start, going forward to that because we're covering maps anyway right now. So I can show you, let's see. Oh, no, before that, I'm going to show you Google Earth Engine. Okay, so this is another flavor of how you can create your applications directly on the browser. How many of you are familiar with Google Earth Engine? If you can type in the chat, that'd be great. Oh, I see there's some Q&A. Let's see. Oh, okay, so I just answered your chat. Thank you, Maui. Let me declutter this quickly. Let's live. Okay, I see some people very familiar with Google Earth Engine. Perfect. That's great. Subot says that he's also familiar, so that's great. So I'm just gonna go over the very simple parts of Google Earth Engine. It has a lot of data sets available for you. It is free of usage. They have a lot of functionalities so that you can take a look of things such as it's all about processing data, satellite imagery, again, layers of information, making some analysis on this information. And they have their own functions that they are available. So it is JavaScript, but it's a different flavor of JavaScript, let's say. And what I like about it is that you have a ton of examples, so many demos, so many information. This one is a modest image. So if I think it's this, let's see. Takes a little bit of time to get the links. If you click on run, ask. Okay, unsubmitted task. I'm going to run this one. No, I'm not going to be doing this right now. So, there you go. Took a little bit of time to run there. So you have terrain analysis. You have, if you are familiar with GIS, a lot of the functions that you can find in this in QGIS, in ArcGIS, in ArcGIS, other programs, you can find a lot of them in here. Is it in docs? There you go. So algorithms for masking, geometric structures, Landsat imagery analysis, Sentinel-2 analysis, temporal segmentations, terrain analysis, terrain inputs. If you want to analyze an array per pixel, you can get some values there. And the great thing is that it tells you exactly what it does. You don't need to be wondering, okay, what can I do with this? Or what can I do not do with this? It tells you exactly what you do. And the examples that they show, I'm going to show you another example. I think it was the classification one. The examples tell you exactly through the small documentation here what it's trying to do, right? This one is classification of terrain through land cover and features from point data. So think about this. You can also think about it as I have a nice GeoJSON that has a land cover, an index, and I have my lat long for it, and I can just put it in. If I click on run, it's nothing right. Let's see, maybe it's going to take some time. Something else also that I should mention is once that's done, once some of this imagery detection is done, so if you want to particularly understand what's happening, you use this print statement in this console, so the buttons are fairly straightforward. And you attach that and print there, for instance, this print explanation. You attach like a variable, you attach, you can console log like I did this modification of a pixel and I want to attach it in here. This one is not clickable, but take a look on all of this. There's many examples. For instance, elevation histogram, I was playing with this one. There's a lot of things that you can play with. And this one is in Colorado, I think. Yeah, in Colorado. So let's say click on run. You get a shape file. Sorry, a raster. This raster is then attached into the map. Then if I go and click in one of the sites, and I click on this one, yeah, you get a histogram of elevations. Right? So that's Google's Earth Engine. There's a lot of different features there. Again, it's free to an extent. There's other stuff that might need you to put a credit card, but there's no need for that. I think for learning is it's a great resource to have. And let's see if I can show you another one that is interesting. Or in here in San Francisco, there you go. Fetches data from the demos that they have. So there is a lot of information here about that. And then you apply filters, you apply joins. If I click on run on this is how it looks. So this is for BART stations. BART, that system in San Francisco. If you've ever been over there, if you're from over there. So yeah, that's Google Earth Engine. Something worth mentioning for today. We already went through the three, went through join for this one. We can go ahead and get started with some of the features of what did I have in here? Oh no, before we finish, yeah, I'm gonna wrap it up with this one. So the afterwards in the afternoon, we can have the creating the dashboard with the HydroLine, creating the dashboard with the Hydro Compute, and introducing a little bit of the Hydro TC, and show you the examples of the good charts or bad charts and real-time analysis on Python, correct? So if you want to take a look into the resources that you want to learn more about visualizations, again, we're either developers or researchers, but sometimes the communication aspect, it's not that it's lacking, but we can improve. So if you want to take a look at some of the resources, I really like this book from Duke University that tells you the charts do's and don'ts. So things as avoiding distortions, things that are fairly intuitive that you would say, well, yes, I wouldn't do that. And then you go ahead and take a look at your data set and take a look at the paper that you created, and you're like, okay, I was doing exactly that. So it's all about someone telling you or reading it somewhere, and then you're like, okay, that makes a lot of sense. So avoiding distortions, right ranges, consistent, simplifying information, creativity on labels too. We didn't talk much about the text that you can append into a chart. So we just mentioning about labels. However, just as a dashboard, basically one of these infographics or one of these charts that contain information about the specific things that it's talking about, it's the dashboard, right? So think about a poster that you have created. Is that poster really showing me the or am I attaching to the poster the information that I want to showcase? So always about thinking outside the box and looking for information out there as well. We we don't necessarily know everything about how to do it, and there's probably someone very smart that did it before us. Don't Please do not use 3D charts. That just looks terrible everywhere. I think that the only time that I saw a nice 3D chart was one of those stacked maps in which if you put many stacks on top, it looks too cluttered. But if you separate each of the stacks and put them as layers, each behind of them, it looks just a tiny bit better than just stacking them together each other. But bar charts never do 3D. Using a lot of colors as well. Oh, that's the last thing as well. Oh, there you go. I have it right here. This palette. So I'm gonna put this in the chat as well. There you go. You go into this happened to me one time. I can share this. Was at a conference and I put a chart, and then someone came and told me, I don't understand your chart. Why? Because I cannot see a particular color. I remember what particular of the different actions were. So it made me think, you're in a public space, or you're showing your data, or you're putting in a publication. When the reviewer, you have a paper and you send that paper for revision. Many times the reviewer, if it's an old school, he's going to print it, and he might not want to put color into the charts, right? So many times using a color palette that allows you to, when someone wants to grayscale it, still be the features to be understandable, that's going to be great for you. Less the reviewing time, less going back and forth to things. So that's something to consider that we need to mention. And so I think show you just a couple of different ways of doing this. For example, dark. You can get the colors in here of what you're editing. So 7 colors, and best practice is 4 colors is more than enough sometimes. The gray scaling, you can have different scales of gray, which is pretty good. And color reporting information. This is a great resource to have at hand when you're making either a presentation or a paper or something to that regard. And I think that we can stop for now, unless you guys have any questions that you might want to ask of now. If not, I think we can see each other in about an hour and 13 minutes or 10 minutes for the last part of our training. So just leave it open for a little bit. You guys ask any questions? Say for 5 minutes. Of course, Galina, sure. So I'm going to stop the share right now. Stop share. Okay, and I'll also stop with the recording, and I'll see you guys in about an hour and 10 minutes. Go ahead and do that. Okay, perfect. And so now I'm going to share my screen. In here, share. Okay. And the document that I was going to post, this one says the dash. No, give me a sec, please. I think it's this one. There you go. Okay, so it's perfect. So we went in and first, before I start with the whole process again of getting nits and grits of the usage of the tools, as we mentioned previously, what are the questions that you might have for me right now? If you do have any questions. I know that some group stayed a little bit afterwards with me. So we discussed, and we can do that, by the way. If you have any questions, please let me know. And I will be able to stay around a little bit further so we can discuss more about any ideas that you might have. However, please just note them. I know that if you want to do something like the web development, that's fair. Do some sort of analysis with Python and then port it back into the um, the web. We can do that too. You just need to tell me exactly what. And we're going to be sharing a document today that contains specifics of how you would do some examples. So yeah, just keep in touch, ask any of us, and we can take a look and help you out, okay? So I went into this resource before the break. I just wanted to highlight this other one before we go into the tutorial space. So it's this one, visualization best practices, again by Esri. So the folks from ArcMaps. We have all that info available, so we can take a look, what a good layer for a map should look like. So with the whole GeoJSON part, if you're using a map renderer, such as D3 Leaflet, you're using Leaflet through Hydroland or the Google Maps, you can change the tiles, the tile system that you're using. And you can also change the um, the colors of, say, you have a KML layer that you want to add. You can change that. You can also change the color of a GeoJSON. So you have a hex, the color scheme for a particular layer, you can just add it. And that's gonna make better for your map. But that, the initial part is just getting the layer out, and then afterwards you see. But once you get into those, you can take a look into this kind of resources that are available in the presentation. And with that, I want to start with the first examples on data manipulation. And I'm going to start with the the whole collab. Was everyone able and had access to the collab, the resources, the charts? If you can, just maybe write in the chat. Yes, no, you have some issues. So I know that if you do not have a collab, I think you can fork it, like something similar to forking, just like copying and downloading it in your local environment. Just once you're here, either you can open a preview or just download as either uh, um, a Jupyter notebook or a Python script. So if it's a Python script, it's just going to run everything. If it's a Jupyter notebook, it's just going to run, well, it's going to allow you to run cell by cell. And the following is just those examples that I put in here in the beginning. How did I got those examples? And I just want to expose you once again to some of the libraries that I mentioned. Matplotlib, Seaborn. Seaborn is for the generation of heat maps. Heat maps are a very good representation of data too, as we mentioned. Matplotlib PyPlot for plotting data. And everyone is able to move that data around to the best way they want. It depends a lot on what you want to showcase in your plots. But I try to keep it simple. There are good ways. There's a lot of articles out there of how to create both good and bad maps. And so in here, what I basically did was I used a random seed generator so that I can append that random seed a value. So, and I created a data frame with a category, value, and groups. For each category, I multiply the category by 10 to scale it up, and I got some value, a random value from 50 here using NP again, and I attached a group, two different groups. And I use this data here for the following functions. So what is a good bar plot and bad bar plot? So we can dive deep into what I mean with this. So it doesn't matter what you're using, it's about how it looks, right? And in here, for example, we define the same figure size, so that's fair. I'm using the bar plot from Seaborn in here to define category and value. I use a particular palette from Seaborn, and I utilize the data here, right? In the bat bar plot, which bat might be a really negative connotation. I'm just saying perhaps this is a better way to showcase it, right? I do within the PLT, I create the bar with the same structure, right? Data category, data value, and I just append a single color blue here. Then everything else is exactly the same. It's just X and Y labels, and then I define it and show. And I did this for everything. I'm not going to go through all of them because that's too much. But lastly, the last thing that I did was I created another function that just calls all these functions together. Just, I'm sure all of you code and whatever works for you is best. But know that if you want to scale up something, for instance, going back into the JavaScript side, you're making several API calls. Maybe just create a function. The functions are going to make it easier for you. And going a step forward, maybe creating a class that changes depending on what you aim to do is better. But that's what everyone can do, you know. So define a function, and afterwards I just call it, and this is how they look. So as we mentioned before, we have a nice palette instead of this very deep blue. So again, starting with the plot that is simple, I'm gonna change this to simple instead. I don't like that. I think it's too much. So I'd say simple and enhance. Simple and enhance, no? And what we're going to get is, okay, so I need to rerun it again. So there you go. And okay, good. That should finish fairly fast. Enhanced bar plot, simple bar plot. You're starting off with your analysis. You want to take a look at what's happening with this. You want to start with your analysis and you want to see here. You're already in the end points of your analysis, and you want to put it in your paper. You do a little bit different, right? Give me a sec, please. I have a question here. Luis, yes, of course. I think I shared it with everyone, but if I didn't, share, copy link, done. I'll put it back in the chat. Oh, to everyone, I'll put it back in the chat. Again, this is just the same stuff that I put in the presentation, the same plots to show you how that looks. And you can go ahead and see more. For instance, this is a nice presentation of if you are doing some sort of a seasonal decomposition, for example. How would that look like through error bounds? Or you have like a plot with error bounds, for example. And that's something similar to this, right? You define your error bounds. Give me a sec, please. So another bad example of the same data source, of the same information is this, right? Well, not particularly the same, but if I have a bunch of plots, this looks just terrible. Never do this, please. Good, bad scatter plots, and what we talked about before. This is a really bad representation of a heat map, and I've seen some presentations and it's not saying much. And look at the difference of, okay, I'm going to apply a little bit different of a hue, and that's great. Okay, so yeah, take a look, please. There's a lot of different examples there. You can even utilize this for your projects. If you want to put something in your project that is, let's say it is static, you can generate it in Python because you're more familiar with Python. You actually put it over there. But if you want to add something more dynamic, some interactivity, then you can just generate it in here and afterwards put it back there. But please take a look if you are able to replicate some of these functionalities using D301. And it goes without mentioning, but I do want to mention this. I know that a lot of you guys are new to web development or new to all of this. So if you want to use some of the tools that are now available out there, that you ask a question and you get a little bit of information further, like code or whatnot, please do so to get a sense, a faster sense of how to do something, And that way you can explore the code more in detail, more within your grasp. So this is the first example that I had. There's another question in the Q&A. Okay, I think it's the same one, so done. The second one was visualizing geospatial data. So I'll run this. The first is GeoPandas. So GeoPandas is this library that enables, maybe I can just searching GeoPandas. GeoPandas, here you go. It allows you to use several of the same tools you would find in a system like QGIS, basically a lot of them. In your Python ecosystem in your Python scripts. So it's pretty neat because they have a lot of available examples, and this is one of them. So what I'm doing here is reading a shapefile, this natural health shapefile. Through the, you same idea, you get the library, then you get the function, you read the function through a path. Afterwards, that is attached into this variable. And I say, hey, I know that this variable has different properties. And if you look into world, something before this one, I'm going to run this, but I want to explore world, which is this. Once I read that shapefile and I attach it into a table, so I get basically an attribute table that has a nice panda structure, population, continents, the name of that continent, the acronyms, and the most important is the geometry. So this geometry definition is attached to a particular type of special query that you can make. So from this information, you're able to generate the this part. I'm able to render a map. So I define, hey, I just want to visualize Europe. So then I create, using matplotlib again, I create a plotting space. With the plotting space, I say, hey, plot the world in light gray, and then plot Europe on top of that in light blue. So it's going to use the same figure. And then you just define titles, X labels, Y labels, show it. All of this is in a function, pretty straightforward. And then create the spatial visualization, and this is how it looks. So from there, you can start doing more with your shape files and understanding more, obtaining more features, and the list goes on. Is there any questions so far about the usage of the scripts? These were very simple scripts. Again, I know that for some of you, this is just very basic, but we want to kind of level everyone down. So we are in the same space, and then we start moving to further further examples. There's something in the chat. Let's see. So Claudia says, not sure as it has been discussed later, but there is a rubric expectation for the capstone project and used for data retrieval analysis tools we use. There is, and that was going to be shared afterwards. I'm not really sure if today or tomorrow, but there is an expectation of what you're aiming to do within the capstone project and the utilization of the tools that you have. So you don't have to use every tool, but definitely there's features that you can extract. Yeah. Okay, so moving forward, I'm going to explain the map module of Hydroline. Okay, so what would be easier to do right now? Yeah, I think this is fine. So the map module in the Hydroline library contains functionalities for both the Google Maps and Google in Leaflet. And as any of the other functions within the library, you're able to render, you're able to call all of the functions through the whole parameter arguments and data part, right? So in this example, what I'm showing is how you would declare a map. It's a very fast map. The only thing that you need to do is calling here index.html. You attach the script from that CDN, from the content delivery network. And then in this example, I'm not writing scripts within the HTML. So that's something that you can do too if you don't want to write your scripts directly in the HTML for a cleaner overview instead of writing things right there. You can just separate it and into another space, into another file. In that file, we call it main.js. And in here, I declare the Hydrolang instance, and I created a function similar to the functions that we were doing in here. You define a function, and inside the function, you just put a wrapper, right? So that you can call it afterwards. So the wrapper looks, let me see where I was, right here. So the wrapper looks like this, main, this, well, yeah, I guess I can mention it right now. Async is, this means that the function is going, it has to wait for some data to be retrieved before it finishes. So this is how you declare a function in JavaScript. There are many ways of doing it. You can just follow this structure. You say, hey, this is, the function is called main, and it has this scope. There's no arguments inside. You use this nice notation, but it's not necessary. You can just put brackets too. And I say then hydrolang.map.renderMap, and I call the leaflet library for it to be centered under these stations, under this geographical center, right? And once that's done, I want to call main. So I bring that script into my source, and later I call main, and that's how I get the map. So it's pretty straightforward. You can try it for different locations as well. And from there, adding layers into Hydrolang is another easy feat. So recall how we were doing the GeoJSON files. And you can even explore more on, I think, the link that I shared previously about the stack blitz. Yeah, this one. So that would be a nice trick to do exactly all the same as in here, but instead of using D3, just use Hydrolang by the functions that are in here. So how do you add a layer into Hydrolang? You use, again, the library.map layers, and you pass the arguments. So you have to declare args. You open a bracket notation and you say the type that I have is a GeoJSON. And I just attach a name. You don't have to attach this name. But if I have a layer, for instance, what we did with the dashboard that we can explore once again, is that I wanted to attach a particular name to the stations. And I know the name because it's coming from the data source. So I just grab that and then I just put it in here in the output. And what is the data? Well, this is a very basic GeoJSON that is centering and putting a point inside. There in the parameters, you can declare options for styling, but there's already a default styler there. So this is how it looked like. Oh, it's not rendering right now. This is the file. But yeah, that's how you make those declarations. Okay, so that is part of the map module. Let's go into the visualization module once again, just so you can take a look on how we merge those two together to have the full interactivity in a web application. And this is done through the visualize module. The visualize module is hydroland or visualize or draw. And then you want to draw something, you just define either it's a chart, it's a table. What kind of chart is it? Then you pass it as an argument. So this one is a column chart. And the column chart, what do I want to render in the column chart? If you have multiple columns that you want to put in, or if you have like a time series that you want to put in, say that uh, you have 4 different features and you have names for each of the features. So you would pass the name of the feature in here in the arguments as strings, and you pass the data as a collection of arrays. So an array of arrays, basically what you have in Python, the concept of the lists. So a list of lists, right? And once you do that, you can just copy paste. So I made it more interactive for this side, so you can copy this and you put it right there. And then you get this fast chart space. So now imagine if I have more complex data sets, this is going to go bigger. There's going to be, again, this is using the Google Charts API. So Google Charts is, in my opinion, is not as robust, I'd say. Not, it's pretty robust actually, but it's not as it's not as what's the word that I'm looking for? The Google Charts is not as custom. It's not as pretty. Let's say, yeah, pretty is a good word. It's not as pretty as any other libraries, and some of the other libraries that are out there are building up on the Google Charts. So you have to take that in consideration. But yeah, that's how you declare this. And there's the line charts. There's other stacks as well. And just I'm gonna go back into the visualization deck so that we can explore it a little bit further right now. And what we do is I'm going to put this in the sandbox. So what did we do in here? We attached a map. We attach each of these ones are API calls that have been cleaned. If I go into source main.js, by the way, if you like, you see that this is overflowing. For most editors, you're able to just Alt Z if you're in Windows to, so that's not overflowing. Everything is just going to the next line. So the example that I'm giving in here is you have your data, you retrieve it, you append it in here in the data object, and you transform the data. And from the raw stations, which is a collection of objects, so it's an array of objects. Again, what is the difference between an object and an array? An object has properties that are clearly defined. So for example, a station, this is a for loop, by the way, this is a version of a for loop in JavaScript. I say, grab the raw stations, and for each of them, so basically that notation in Python of for x of x in x, something similar to that. For all the objects, for all the collection inside the list, I want to create a new object that has the following properties. The property name is going to be for each of the stations site info, because I know that when I see this variable, in my, when I retrieve it, I see there is a site info and there is a site name. I know that there is a location which is accessible through siteinfo.geolocation.geolocation. I know that there is a code, site info, site code, and so on. So I am appending all of these properties into here. And once that's done, I create a new variable called clean stations, in which instead of having all the metadata that I just received from the JavaScript side, from the API calls, I just keep the most important ones. And I use that also to render the stations inside the map. So once that's done, all the stations are going into the same process. If there is a problem with a single station, then it's not going to be processed. For each of the stations that is now in this clean array, I append a button and I call it, hey, retrieve data. So a button, this is basic JavaScript, just this is how you create it, document the create element. And it's like a floating point, a floating object that is out there. And then once I am ready to attach it to something, it doesn't necessarily have to be to an HTML directly, then I just called another function for doing that. And I put inside the name retrieve data. And once I click the button, it's JavaScript as well, button.add event listener, and event listener is what is the interaction that the user is having, what particular interaction is the user having. For example, click. So if I click in here, then I will or not will get data, but I know that I'm going to make a request. So if I make click, then I define a function, and this function can also be put outside, right? And the function is called retrieve values. Retrieve values, and what values am I going to be retrieving? The site code. If you go back into exercise 1 of class 1, this site code is exactly what we needed to do, right? So for each of the stations that I'm getting back from the API, I know that I'm going to get a property called site code. And I go ahead and just use that site code to make another call with Hydroland. So if I go into this retrieve values function, which is down here, by the way, since there are functions and in JavaScript, everything is done from the top down as well. It doesn't matter where you're declaring things. And this is a clear example. I declare the function down here. And that function, what it does is it creates this overlay and uses the site to make the API call into USGS, again, daily values. So some of you folks were asking about the water quality data. This is where you would change the endpoint. So you know that USGS or any of the other sources through Quasi has, through the get sites by box in Quasi has a station there that you're interested in, that you want to explore. Once you get that station, then you will make a separate call to the service that is available on the library. And the way you do it is by creating a separate query. And the only difference is that since this is dynamic, each time that I'm touching here, it's just appending that site and the site name. And I'm just using this site in here. And you can modify this, of course. There's a lot of different interactivity levels that you can add to this. I had it fixed from the 1950s to 2023. It'd be interesting if you, once you click, it asks, okay, what are the date ranges that you would like to get your information from, right? Because thinking about data reliability, what if I don't get correct data from the 1950s, but I know that I might get really good data for allocation from 20 years ago, 20, 30 years ago, right? So from there, I can just apply some statistics, some basic informations, um, from basic information regarding the tools that I want to develop. So I make the call, I append that into this USGS variable that I need to wait for it to come back. And then once that's done, so all this below has to wait for this to be finished. And then we attach that into the visualize component. So what we do is we call hydroline the visualizer draw. I want to draw a chart and I want to name it retrieve data. So let's try one chart that is one location that has Weber. So this ID here is the one that is attached here. And you can even move this around a little bit and say, okay, I don't want to call it retrieve data, I want to call it something else. That's fine. But not only am I going to attach this here, I'm also going to create a table. And what I'm going to do in the table is I'm going to use the descriptive statistics functions in Hydroland for just getting the sense of the data. We went through this on Monday, and what you do is hydro.analyze stats, basic stats, and then you pass the USGS data back in. And everything else is just displaying or not displaying things. So if I click outside, it hides this overlay. So overlay is when you make it gray, it's not disappearing, it's just making it gray, making the page gray. That's all. It's just like a visual trick. And if I click on download, then I'll be able to download the data, I think. To download data as from Hydroland, you just use hydro.data to download, or the arguments that you want. You define that, and what is data to data. And that's all on this regard. Now, that's not the only things that you can do with Hydrolang maps. We also have a good development done by a master's student who added flood estimation and mitigation layers into the library. And we released that in the latest release from the node packaging system, so 1.1.10. And that's what I'm going to show you right now. So from the example that we were talking about yesterday with, okay, my first HTML page. My name is Carlos, WaterSoftHack2024. I'm going to say day 4. I changed just the version in here. And I say, okay, I want version 1.1.10 and declare the library here. Okay. So once I save that, that's going to appear here. And what is flood damage estimation and mitigation? Well, that feature is here explained in the documentation of the library, in which what we're trying to do is to have, say that you have point data and you know how much you attach a price to the point data based on the occupancy level. So this is some work that you take a look into local resources, local agencies that provide information about monetary value attached to flooding. So that's perhaps another case study for you guys to explore. And how much money does this actually cost for me to get a um, enough to get a house in a 500 plane event, in a 500 floodplain, or a 200 floodplain. How much money am I expecting if I have a bunch of buildings, right? So if you want to take a look into this, there's some really good information on how to declare that. I'll show you a quick example on how to use this. So what do you need? It's JSON files, GeoJSON files, KML layers to calling those data layers and append them into a map. And a lot of it is just good definitions of a multiplication of one thing between the other, or perhaps just fetching data from a public resource that is telling you for a city, for instance, Iowa City, or I'm going to show you some examples of Cedar Falls, which is an area that was flooded some time ago, usually like this. How does that look like for us? And I will show you that right now in here. Sorry, I know that you guys do not see the bar from Zoom, but I have to move it around quite a lot. So the first thing, I know that hydrolang is declared, and I want to go to the analyze module, and the analyze module is in a hydro.stats, a neural networks, and the component is floodDM. And this is called, what's it called? You can just extract parts of your library. It's like an import statement in Python. So import matplotlib.plt from plt, as plt or something. So you just rename some functions. And then afterwards, I'm going to say, hey, scenario, so it's a variable, is going to be this not new floatDM. So floatDM is a class. And from there, you have different options of depth that is attained to that particular scenario. If a map has been rendered, what is the city option that you have? And we have, as of right now, case studies. So one of the case studies is this set of falls area. You can render both the leaflet map or the maps from Google Maps. And these are point locations that have the geographical information there. So there might be some out there too that you can use. And the scenario is a 500 floodplain. So what you need also is a JSON object that has the flood map scenario put in place. When you click on this, makes a bunch of API calls, and afterwards it renders a map. And this is still not well structured, but you can see some damage estimates in here. There's a bunch of layers that are being rendered at the same time because I rendered the two for the initial damage scenario. So I'm going to close this. And as you can see, it's leaflet map. You can expand it to make it a little bit closer. And the different layers that you can see here are explained. Flood extents, if there's a utility that has been damaged, what is the building damage per scenario. So this is the floodplains of an example is, okay, I want to see what this green building, this bridge as a building here, is all about. There is some metadata applied to this. So the level of occupancy, the grid system, if there is damage estimations, there are debris and other information. Something that you can do with these maps too, and I guess I didn't mention it before, is that you don't have to display all of this at the same time. You can just remove layers. You say, okay, I just want to display the floodplain. Thank you. So that's the initial step that I want to deploy. Right. And I'll stop with this as of now. Please take a look into this. It's available again in option in launch 1.1.10. And I will There's some questions and problems. Let me see. Where can we find the slides for the session? So all the slides, sure if they have been uploaded already, but they have been shared with the team, and the team is going to make them accessible to you. We also have the YouTube sessions. So all of this has been recorded and is being put into a YouTube channel that is shareable. And there's another question: is it possible to make analysis in Java and JavaScript like machine learning without working in Python? Yes, there is. So that's something that didn't show in here, and perhaps Tefera, we can discuss a little bit further. Hydrogen does have a neural network component to it and some machine learning component. And we're using TensorFlow. So I'm not sure how many of you guys are familiar with TensorFlow. Is this, let's say, I'm gonna look at it right now. TensorFlow. TensorFlow. .js. So we're using the JavaScript version for TensorFlow. And thank you actually very much for mentioning this, because you can also use this as part of your analytical process. And it's not hard to implement a simple machine learning model that is already pre-trained with TensorFlow JS. So there's a bunch of tutorials in here. It tells you exactly what it's doing. It's using a lot of the same information as, a lot of the same algorithms as as if you were using Python. And it's optimized because it's using the GPU. So a lot of the development on TensorFlow is going GPU, as you may know. Much of what you do in machine learning and AI is basically a lot of complex matrix computations, but matrices can be parallelized. A lot of the tasks can be parallelized and put into different spaces. So take a look into this if you're interested. In Hydroland, we have a shallow neural network that is available through TensorFlow as well. There is documentation on how to do a simple feed forward over there. And there's the tutorial. You can, as we have done with all the other scripts, you can just call it like this, and you can run a simple example. So I'm not going to go in deeper on how to do this, but definitely the resource is great for anyone who wants to do a little bit of development too. And I'll put this here in the chat. So in case you guys want to talk a little bit more about that, we can discuss it further. Okay, there's other questions, question and answer. Really thanks. You know before. Okay, perfect. I'm glad that we're answering these questions. Okay, guys. So I think we can leave the next 5-6 minutes for questions and answers. I don't think I have anything else to show as of right now. We can always go back into the different spaces, particularly documentation or the materials. I did not introduce the Hydro RTC. However, if you want to take a look into that too, it's available as Hydro RTC. There you go, which is a peer-to-peer communication library. And if you want to learn a little bit of how to deploy what's it called? Node applications, so server-side applications, this is a library for you. And the case studies tell you how to create a server-to-peer connection. Again, it's running on the Stacklix and the boot container. The only thing that you need to do is it's a little bit different, the development when you have server-side applications than if you have client-side, because on the server side, you're relying on another kind of JavaScript interpreter. So just consider that. Yeah, take a look and let me know. And I think I'll stop right now. I'll stop my share as well. It has been really nice to teach you all these tools. Please ask any questions. Don't be afraid. We're all here to help you out. In any of the data analytics tools, I know that we covered some complex, some simple stuff. More than anything, it's just the background of why you need this and why is it good for you. So please let us know if you have any questions and if you want to discuss more about the project ideas that you have. I don't know if there's anyone wants to say anything. By the way, we'll be sharing that document that we talked about, the project ideas and the expectations. Also, how the structure of the document should be like for the final report. Well, worth mentioning, next week is AGU, so if you're planning to submit an abstract or something similar to this, both on your research, but largely encouraged for you to do it for this with these ideas. Please keep that in mind. Yeah, so we discussed it a little bit. The Q&A says, what's the expectations of the capstone project? That's going to be shared with you soon. Okay, I think I'm going to stop then the recording. Again, everyone, thank you so much for attending. Yes, of course, you can just shoot me an email. I'm going to be around anyway for tomorrow and for next week. We can go into particular discussions, specific discussions with any of you of the groups, the ideas that you have, how to achieve it, what is needed, what tools you might want to utilize. And definitely I'm available, so shoot me an email too if we want to discuss more. Okay, perfect. Guys, thank you so much. I'll start the recording right now.